The thing about these Pahoehoe flows is that when they form first, they will break out as very thin flows and they will advance very rapidly until the front starts to cool and slows down the advance, and then it starts to inflate behind it because you're pumping material in. It doesn't advance as fast as you're pumping the material in, so they inflate. And the minute it breaks out like this, initially the skin is viscous, you can stretch it, but then it thickens, so the outer part cools and becomes solid, and you have a viscous layer underneath it. That viscous layer is very important because that actually holds up the crust. And as you put more lava into this lobe and then through it, the crust will thicken from beneath. So you add in material to the bottom and the thing keeps inflating. And what you see in here is actually the result of that. So that crust formed on this lava during emplacement by this accretion process and this inflation, and hence the thickness of it is a measure of the time it took to emplace this lava, because the growth is a function of conductive cooling. So you can basically use the equation for conductive cooling, you can extract time, and my guess this one, it's less than a meter, it's about 80 centimeters thick, maybe up to a meter, so we're talking about 2 to 3 weeks it took to emplace this lava.